Here's a quick video on interval notation. So if we want to describe a set of numbers in algebra, we need a quicker way to do that. All right, so let's start out by thinking about a game. All right, we're going to play a game here. So here's the game. The game goes like this. Let's say I'm thinking of a positive number that is not larger than 10. Can you guess it? Well, there's a bunch of numbers you can pick. All right, you can think about your number. All right, give you a second to think about it. All right, you got your number picked. Well, the number I was thinking about was 2.71828. Is that the number you guessed? Well, you probably picked a whole number like 1, 2, 3, 4, 5 or something like that if you were playing along. So the idea is there's lots of numbers between 10. In fact, this will blow your mind. There's actually an infinite amount of numbers between 0 and 10. All right. So how do we describe all those numbers? If there's infinite numbers, we can't list them all. So we need a quick way to do that. All right. So we may, an interval, first of all, this interval that we just described here is from 0 to 10. That's called an interval. That's a chunk of numbers, all right? That's called an interval. So we're talking about all the real numbers that are greater than 1 and not larger than 10. That was kind of the rules of that little game. So as an inequality, we can write that like this. We can say, if we're talking about the numbers that are bigger than 0, so they're greater than 0, x, the number you picked, has to be greater than 0, but x, the number you picked, also has to be less than or equal to 10. Okay? Now we're going to introduce something called interval notation, and just another way to write that is like this. We're going to put 0, 10, because those are kind of the boundaries. And then we're going to use what we call a soft bracket on the left because 0 was not included, and a hard bracket on the right because 10 was included. All right, so we call these soft brackets here, okay? These round ones, we'll call them soft brackets. These square ones we'll call hard brackets. Not sure why somebody picked that. All I can think about is if you were falling from the sky and, okay, here you are, and you fell on one of these, you'd probably bounce off. If you were to fall on one of these and hit that corner, that would really hurt. All right, corny joke, but that's how I remember. So let's do some examples, and we'll get a feel for this interval notation, all right? So here we're going to describe a group of numbers. Here's a chunk of numbers. X is a number that's bigger than, greater than or equal to 0, and less than 5. Now, if we're going to graph that, we can do this. You hopefully have some experience with graphing on a number line. So x is between 0 and 5, but we're going to put an open dot at 5 and a closed dot at 0, and we'll shade it in between. So these numbers are between 0 and 5. 0 is included, 5 is not. So in this case, we would say these are the numbers from 0 to 5. 0 is included, so it gets a hard bracket. 5 is not, so it gets a soft bracket. Make sense? Then something like what we did earlier, but this is different than the one we had here because notice 1 and 10 are not included. So this is the numbers, it's bigger than 1, less than 10. So we have 1 and we have 10. And neither of them are included, so we put an open dot if we're graphing with dots or points. And all the things in between there that we would shape, all right? So that would be from 0 to 10, soft brackets on both sides. Now, the last kind of inequality doesn't have boundaries on both sides. These have boundaries on two sides. What if we just say x is greater than 3? Well, so 3 is a cutoff number. 3 is not included. Notice it's not or equals to, so that's going to be an open dot if we're graphing it like this. And these are, if we wanted to shade these numbers, the numbers that are included in x is greater than 3 are all to the right. So that means it starts at 3. 3 is not included, so we get the soft bracket. Well, how far up is it going? Well, it doesn't end, and we use the symbol infinity. That's a bad one. Infinity is a sideways 8 to mean it goes on forever up to the right. All right, and what kind of bracket are we going to use? We're going to use a soft bracket because we never actually hit infinity. All right. Then one more. What if x is less than or equal to -2? Well, on our number line, we got -2. Where's all numbers that are less than it? It's to the left. This is or equals 2. So it's going to be a closed dot, a filled in dot. So that means 2 is our upper boundary, our right-hand boundary, -2. It's included, and we're going down to the left. Where are we going down to or towards? Well, we say negative infinity. Infinity is not a number. We never reach it, so it's a soft bracket. And there it is. So that is interval notation. And that's how we quickly describe a group of numbers. We'll use that a lot for domain and range, and describing the groups of numbers that work for the domain and range and other concepts in math. All right, hope that helps. Thanks.